The next topic in the course is everybody's favorite, and I do mean that with some bit of sarcasm, and that's how to graph inequalities. So far we've talked about lines. We've talked about equations that just go in one direction. There's no squiggles in them. There's no up and down to it at all, and it's just a straight line, and that's it. The next step in understanding how to graph things is to graph inequalities. And really, if you know how to graph the equation of a line, graphing an inequality is really no sweat. So without talking about it forever, let's just dive into a few examples, and I think you'll get the idea. What if you had an inequality that looks something like y is greater than or equal to 3 minus x? There's a few things I want to say about this, but I think in order to say them, we need to work through an example first, and then we can move on from there. First thing I want you to do when you're confronted with this is totally ignore this symbol right here. This means greater than or equal to, but for right now, I want you to pretend it just says equal to. I don't want you to even contemplate the fact that we're working on an inequality here. So let's do that. Let's draw our axes like we always do. Okay? We'll draw them like this. This is x, this is y. Okay? Another way to write this equation is y is greater than or equal to negative x plus 3. I retained the symbol here, although I want you to kind of forget about it. All I did was flip the order of these two things because we generally have been working problems with the x written first and the y-intercept second. So, how do you work this problem? Let's go ahead and make some marks on our board like this. So this goes 1, 2, 3, 4, 1, 2, 3, 4, 5 like that. Let's plot this as if it were a line. The y-intercept is 3. 1, 2, 3. So I'll put a dot there. Easy so far. The slope is negative 1, which remember, the slope is rise over run. It's negative, so I'm going to rise down to the bottom and go over 1 because the slope is negative. I'm going to put a dot here. Now, if this were just a simple equation of a line, I would draw the line and that would be it. So let's pretend that we're doing that. Okay? Now we've got our line drawn. Cool. But this is not the equation of a line. This is an inequality. What you do is you pretend there's an equal sign there, you draw your line, and then you have to shade some of this graph. And I'm going to shade the proper part and I'm going to explain it to you. The solution to this problem is everything above this line to be shaded. You have to pretend here that that's a nice shade there. Okay? So the solution, or the graph of this, is this line and everything above it, all and up to infinity, all up over here, all up over here. Nothing down here is included in this graph. And the reason that kind of makes sense is, what I'm saying when I say y is greater than or equal to this is, what I'm saying is, if I draw a boundary, what this represents is everything greater than or equal to this set of points called a line. So everything above it, greater than, because bigger numbers in y go up like this. So it's everything greater than. So all you need to do is draw your line, figure out if it says greater than or less than, and then shade appropriately. If this had said less than or equal to, well then I would have shaded everything below, because it would have been everything below less than on that line. Okay? Let's do a couple more examples, and I think things will become clear. And I also want you to notice that this line here, I drew it as a solid line. And I will explain why I did that in a second when we get to the next problem, actually. But I want you to kind of keep track that that was no accident. Let's say I give you y is less than 2 minus 3x. Notice it's not less than or equal to, it's just less than. Okay? I'm going to rewrite this and say y is less than negative 3x plus 2. First thing you do, just like before, you plot that line just like you're plotting an equation of a line, and you don't even have any idea there's an inequality here. So I draw some tick marks like this. My y-intercept is 2, so I'm going to come up here to y equals 2, and I'm going to put a big dot like that. My slope is negative 3, which means rise over run, remember, but it's negative, so I'm going to rise downward. 1, 2, 3 over 1, which is here. Okay? Now I'm also going to draw a line just like I did before, but I'm going to draw a dotted line instead of a solid line. And I'm going to explain it to you in just a second. To finish everything off, we need to shade something. And actually to do that, I'm going to use a different color, which I think may be beneficial for this example. And what I'm going to do is I'm going to shade everything over here. Just like that. Okay? This is the solution to this problem. Okay? We drew our line and we shaded everything below it, because what this is saying is, to graph this, y is equal to everything below this line, less than this line. Okay? But it's not equal to the points on this line. If it said less than or equal to, I would have drawn a solid line. I drew a dotted line here, and that means that the points that are satisfied by this inequality are all of the points below this line less than this line, but not including the points on the line itself. So I've got to draw something here, so I just draw some dotted lines to let you know where the boundary is. But the real solution of what you're drawing up here is actually everything below it. So that's not too bad. So really the thing to remember is, when you're graphing inequalities, really the only trick to it at all is to use a solid line when it's like greater than or equal to, and to use a dash line when it's like just greater than. So if you had y is greater than or equal to 2x, okay, how would I do that one? Well, I'd draw my coordinates here. I'd put some tick marks like this. The crucial thing to remember here is, well, what's the y-intercept? Well, there's nothing here. Well, that means the y-intercept is 0, because it's just not written there. And to draw the line, I've got a slope of 2, which is a rise of 2, 1, 2, a run of 1, because 2 is just like 2 over 1. So I put this here. What kind of line do I draw? Is it dashed or is it solid? Well, this is greater than or equal to. So I draw a solid line. And then the final thing to ask is, y is greater than everything. So what you do is you put your pencil on the page and you move up from this line, because y is greater than the points on this line. And so to better show that, it's all these points over here. All of them, all the way up to infinity. Okay? And don't forget, this line goes on and on forever, so it's literally everything above that line, because it's greater than 2x and equal to 2x, so it's everything on the line as well. If I had less than, of course, it would be everything on the other side. Let's go ahead and do another example of this type, a little bit different. 2y minus x is less than 8. Well, obviously this looks a little bit different. The only thing you need to do is solve for y, and then you can proceed as usual. So you've got 2y is less than x plus 8. All I did was add x to both sides, so you got x plus 8. Finally, y is less than 1/2 x plus 8 over 2 is 4. And all I did to get from this step to this step is just divide both sides of this thing by 2. Of course, the 2 goes away on this side. Right in front of the x, I'll divide by 2, so I get 1/2. And then over here, 8 divided by 2 just gives me 4. Like that. Next step is, go ahead and graph it just like it were in line. The y-intercept, remember this is x, this is y, the y-intercept is 4. 1, 2, 3, 4, so I'll put a big dot there. And my slope is 1/2, so that's a rise over run, rise of 1, run over 1, 2. So that's somewhere like that. Now, it's not equal to, it's just less than, so I'm going to put a dotted line instead of a solid line. And then to finish everything off, the actual graph here is the set of points less than this line, which means everything underneath it, like that. And that is exactly how you would draw it on your paper. You draw the 2 points, the dotted line, and you would shade with your pencil everything underneath it. I'm going to do a couple more examples. They're just going to get a little bit more difficult, but really none of them are really difficult. The first one is 3 parentheses x plus y plus x is less than 6. And this is just giving us a little practice in simplification mainly. So first thing I'm going to do is distribute the 3 in. 3x plus 3y, that's just distributing the 3 in, plus x, I just kept that the same, less than 6. I can combine 3x and x to make 4x plus 3y less than 6. That's easy enough. Now, the next thing I really want to do is I want to solve for y. So I'm going to say 3y less than negative 4x plus 6. How did I do that? I just subtracted 4x from both sides. So it disappeared from this side and it popped up as a negative 4x over here. And finally, to get y by itself, all I do is I divide by 3. So I've got negative 4/3 x plus 6 over 3 is just simply 2. Negative 4/3 x plus 2, and this is what I'm going to actually work with here. So if I were going to graph that, I would have that. You've got to look for your y-intercept, which is just simply 2, right there. And then finally, I just use my slope to get my next point. It's a negative 4/3. That means I rise over run, but it's negative, so I rise downward. 1, 2, 3, 4. Run of 1, 2, 3, which is right here. There's another point. I want to draw my line here, but this is a less than, not a less than equal to, so I'm just going to put dotted line instead of a solid line. And then finally, to finish everything off, you've got to figure out where do you shade it, on what side of the line do you shade it, and y is less than, which means lower than everything on this line, which means everything underneath, like that, is actually what gets shaded. Everything below. Okay? So you see, that problem really wasn't too hard, and really the rest of the ones I'm going to do are similar. You just get some expression, you simplify it, and then you move forward. Okay? The final one I'm going to do here is 5 times x minus 2y is greater than 5x. And I want to plot this inequality. So first thing I'm going to do is I'm going to distribute the 5 in. It's going to be 5x minus 10y. 5 times x is 5x. 5 times negative 2y, negative 10y. Again, greater than 5x. Okay. And then I want to get y by itself, so I move 5 over here. So I have negative 10y greater than 0. Okay. So I move that over, subtract 5x, that gives a 0. Subtract 5x from both sides, I get a 0 here. I want to get y by itself, so in order to do that, I need to divide by negative 10. Okay, so all I do is I divide both sides by negative 10. Okay, so on the left I get y. On the right I get 0. 0 divided by anything, 0. This is something very important to remember with inequalities. This is one of the only things I'm going to ask you to memorize. Anytime you have something like this and you divide on an inequality by a negative number, which is what we're doing here, the sign of this thing has to flip to the other direction. In all the other examples when we were working on this, when we were to simplify things and we would solve and divide, when we want to isolate y, we would divide by something on both sides. It was always a positive number up until now. So this inequality, this arrow, always stayed the same, never changed. In the case when you divide by a negative number, you flip the sign. Don't ask why. It's something you could go off and research, and if you found it very important to you to try to figure that out. But this is just something you need to know. When you divide like this, you got to flip the sign around. So we want to plot this equation. It looks a little bit different than the other equations we've plotted. Okay. First of all, remember we did a little bit of talking about equations that kind of look like that. What if the equation were y equals 0? Well, what that would mean that no matter what x is, remember this is x and this is y, no matter what value of x is, y, which is this value, is always 0. So that would mean that the line, if it were actually a line, would be right here. Okay? It would be right along the x-axis, which is exactly what we want to do. But, however, remember, This is an inequality, not a line. So what we want to do is we want to draw a dotted line here because it's not equal to. So this is 0. This is y equals 0 right here. No matter what value of x is, y is equal to 0. Okay? And what I'm going to do is I'm going to shade something, and I'm going to shade everything underneath it, like this. Okay? Because I have y less than 0, the line is y equals 0, and I'm interested in everything less than that, but not including the line itself. So that's why I kept it a dotted line there. That's about all I wanted to talk about inequalities. I think we did a pretty good introduction to it, and that concludes the first part of this video series on graphing. We've talked about graphing linear equations, graphing equalities, slope, point-intercept, and all those things. In the next section of the course, we're going to move on and we're going to talk about systems of equations. When you have two lines and you try to find out the solution of that system of equations. And that's what we're going to work on next.